So the first step is going to be to simplify. So here I have written my tangent as sine over cosine. Now keep in mind that this tangent, all of this is the denominator when we rewrite it, because that came from the tangent of pi y. So that is what we are going to flip when we do the keep change flip. So what will happen is you will get sine of pi y times, and then the flip of this denominator, which would flip it to be cosine pi y over sine of pi y. Okay, and then what's really neat about this is that then you see that sine of pi y is canceling out. Now do keep in mind, when you cancel that out, that means that you have a removable discontinuity. And that removable discontinuity happens when sine of pi y is equal to 0. So that's actually going to be a trig equation that we need to solve. Before we go on to that though, you do want to ask if there's a non-removable discontinuity, and there's not going to be one, because when you look at just cosine of pi y, there's no denominator left over. So the only type of discontinuity that you're going to have is going to be generated from this sine of pi y being crossed out as a removable discontinuity. Now, when you look at this trig equation, you want to notice that it's a multiple angle trig equation, and it's multiple angle because of the pi, that factor of pi. So the first thing you do is you let theta be equal to pi y, the argument of the trig function. Then you go to your unit circle and solve that resulting equation. And then the third step is that you go back, you switch back to the fact that theta was the angle, the pi y. Okay, so what you would do is you would start by letting theta be equal to pi y, so that gives you sine theta equals 0. You then go to your unit circle, and on your unit circle, you're looking for where your y coordinate on the unit circle is equal to 0. And that, of course, is going to be at 0, at pi, at 2 pi, 3 pi, all the way around. So we summarize that to say that that's going to be when theta is equal to n pi. And n here is just any integer value. Okay, so once you get that theta is equal to n pi, then you switch it back to your original argument. So you would say theta is pi y is equal to n pi, and then solve that resulting equation for the variable, so divide by pi, and you get that y is equal to n, where n is any integer. Now, by the time you get through all that multiple angle stuff, it's easy to kind of forget what you were doing, but this was telling us the removable discontinuities. So this is saying that we have removable discontinuities at y is equal to n, where n is any integer. Now, for this particular problem, they gave us a special y equals 1, and y equals 1 does satisfy n being an integer, and so yes, the answer is yes, there is a removable discontinuity at y equals 1.